Now, welcome back again. We've spoken about the types of quadratic expressions or equations we can have. In the previous video, we spoke about the monomial, the binomial, the trinomial. We can have more. But basically, we mentioned that our quadratic square plus bx plus c is equal to 0. This is general form in a quadratic equation, right? Now, look at this question. And don't forget, if there is no equal to 0, then equality sign becomes a quadratic expression. But having this, look at this. Let's compare this with this. Question 1, let's solve. Already, we have this. Right hand, left hand, they are factors, right? Then we can factor out something from there. We have 2x squared 32. 2 is a factor of 32. 2 is also a factor of itself. So we can bring that out. Or before we do that, bring this here, make it of this form. Let me be of this one, the quadratic equation. So we are going to be having 2x squared 2x squared minus 32 is equal to 0. So this is really a quadratic equation, right? Now from here, in this form, we can simplify it again. Because I'm seeing two values that they have squares here. You are able to divide 2 by 2. Simplify further because you can factor out something here. So we are having 2 open bracket x squared minus 16 is equal to 0. So from here, we can divide 2 by 2 to get rid of this 2 so that we can have only this and this at the left hand side. So we are going to be having that we divide 2 by 2, divide 2 by 2. This cancels out this, so we are going to be having x squared minus 16 is equal to 0. This is where we are coming to. Factorizing the difference of 2 squares. These are difference of 2 squares. What's the meaning of difference? It's a minus, negative sign, means difference. 2 squares. X raised to the power 2, this is a perfect square. It is a square. 16 is a perfect square because we can write this as x squared minus 4 squared. Right? Then from here, we are done. What do we do? Permit me to finish up here because of the one right down. So we have this here. Whenever we have difference of 2 squares, pick this first step and the second term. That is straight logic. Pick this, we have x. The first step, minus, leave their powers alone, leave their squares alone. This, minus 4, close the bracket. Then this, open another bracket, this, plus the second term. We are factorizing this, right? So we are able to say x minus 4 can be equal to 0, this equal to sign, or x plus 4 is equal to 0. These are the factors of this equation. But for the roots, here we have, equate each of these factors to the 0. Then from here, x can be equal to 4, or x is equal to minus 4. That implies that what? X is equal to plus or minus 4. We have solved that question. Do you get it? That is as direct as that. Let's solve the next question very fast. So with the next question, we are going to be having let's start from here. Let's start this from here. Now we have more space. So from here, what do we have? P is equal to difference of 2. You get it? It's going to help us to do everything that we want to do. It's going to help us. So what can we do? We have 2 whole number, 7 upon 9, x squared. And we have the square root also. Simplify this by making it improper fraction. 9 times this, we have 18. 18 plus this, that is 25 upon 9. Yes. 10 plus 7, yes. So we have x squared, then minus 1 squared of 16 upon 81. That's 4 upon 9, right? The square is a perfect square, right? So this is a perfect square, so we add y raised to the power 4. Do you see that? Then from here, what are we seeing? This is a perfect square, this is a perfect square, right? So we can write this as 5 upon 3 all squared. So this is 5 upon 3 all squared, then we have x squared, right? Then minus 2 upon 3 all squared, then y raised to the power 4, right? Now, look at this part. 5 upon 3, 5 over 3 acts to power 2, x equally acts to power 2, 2 over 3 acts to power 2, y raised to power, y is having power of power 4, I mean degree 4, but we can split that degree 4 into y squared times y squared. Then we can combine their powers. So what do we do next? Let's write here, so we have 5 upon 3 x all squared, then minus 2 upon 3, this one y squared, everything squared. I've written this again. This is, I've splitted this one, giving them power 2. This one is power 2. So by the time it expands, it becomes power 4 back. So power 2. This one, power 2, power 2. You are good. A square is square. First term, second term, squares. So take the first term minus the second term, close the bracket, then let's do that. So we have what? 5 upon 3 x minus the second term, 2 upon 3 y squared, close the bracket, then open another bracket, the first term, 5 upon 3 x plus 2 upon 3 y squared. We've written both first and second term. We have factorized. Well, we can simplify further, right? Something is common to the denominators in the first and second brackets. So we are going to add 1 upon 3. That's what is common. 3 are denominators. That's 1 and 3. Then we have 5x minus 2y squared, right? This one to 1 upon 3 is common. Then we have what? 5 upon 3. Well, 5x rather. Then plus 2y squared. Are you seeing that? These guys, you can bring them out. So we have 1 upon 9. Then we have what? 5x minus 2y squared. Then here we have, again, 5x plus 2y squared. We are done. This is the factorization of this. Thank you for joining me. We meet in the next class.